Hello my friends, congratulations again for having implemented your first classification model, Logistic Regression. And now, before we move on to the next model, I would like to make a classification template that will allow us to build much more efficiently the next classification models of this part. And not only that, it is a template that you will also be able to use for your personal dataset. Alright, so let's do this. At the top of our studio, we're going to click File and then click New File and then our script. Alright, and we're going to save this as classification template. Alright, then we click Save and you will see it appear in your file here. That's the new R file we just created. Alright, then we're going to take our logistic regression implementation again. We're going to select everything, copy it, and then paste it in our classification template. And then let's change the title. We're going to replace this by classification template. And then in the data preprocessing sections here, we're going to keep everything as is, except one thing. We're going to add one line of code that will make sure the classes of our dependent variable are indeed classes and not continuous numbers. So for most of the models like logistic regression, KNN, naive Bayes, SVM and kernel SVM, the package that we'll use to build those models will recognize the classes of our datasets as classes, but there will be two models that we'll build, which are decision tree and random forest, that will not recognize them as classes. And therefore, to make this template applicable to all the models we're going to build in this part 3, we just need to add this little code section here that I'm going to call encoding the target feature as factor. And that will make sure that the purchased dependent variable of our dataset will be encoded as factors. And to do so, we use the factor function, inside which we enter first the dependent variable column, which we access from our dataset, then adding $1 again, and then there we go, purchased. So that's the first argument of this factor function. And then we just need to specify the two classes here with this argument levels that will be equal to our two classes 0 and 1, which we have to enter in this C function, which will take as input 0 and 1. All right, so let me recap this. This line of code is optional for the logistic regression model, the k-nearest neighbor model, which we'll implement next, then the SVM model, the kernel SVM model, and the naive Bayes model. And it is compulsory for the decision tree classification model and for the random forest classification model. Alright, so I just want to include it here so that we can apply this template to all the classification models of this part 3. And for that, let's make the other required changes. So here, when splitting the dataset into the training set and the test set, we don't have to change anything. Same, we can keep feature scaling. And then that's where we will change something. So first we will remove all this because that's where we will build our next classifier. And so we can add a comment saying, create your classifier here. Okay, then we can replace logistic regression here by classifier. All right, to make it generic. Then here, very important, the logistic regression model is the only model of this part 3 that returns first its predictions in the form of probabilities. All the other models will return directly 0 or 1. And therefore, we're going to remove this line. We're going to replace here prop pred by y pred. And here in the predict function, we're going to keep classifier, of course. We're going to remove type equals response. And we're going to keep new data equals test set minus 3. Alright, and this line of code will be applicable to all the remaining classification models of part 3. We won't have to change anything here. Okay, and then same for the confusion matrix. This is only for the logistic regression model because it returns probabilities. And so to adapt this to a model that returns only 0 or 1, well, of course, we need to remove larger than 0.5, right? Because the y pred of our future classification models will only contain 0 or 1, exactly as the dependent variable column of the test set. Okay, great. And then finally, in the last two sections here, visualizing the training set and test set results, same, we're going to remove the probabilities here, then cut this y grid, and then replace this prop set variable by y grid, and then remove the type equals response parameter, so that now we don't have our predictions returned in the form of probabilities, but zeros and ones. And then, of course, we're going to make it generic again by replacing logistic regression here by classifier. Okay, excellent. So now let's copy this because we're going to do the same down there for the visualization of the test set results. So I'm gonna replace these two lines by what we just copied. There we go. And then replace logistic regression again by classifier. And now congratulations, we have a generic template that we will be able to use to build very efficiently our next classification models of part 3. So let's save this and now look forward to building those next models with you. And until then, enjoy machine learning.